Okay, so this is the tutorial on how to make the first one, option 1, the 555 monostable circuit. Now, this is obviously what you'll notice here. I'm currently doing this one in school right now, so it's still the old format crocodile technology. Hopefully at home you'll be using Yenka if you've got access to it, for those of you that have been able to download it. They are very similar. Yes, Yenka's the more advanced version, so you'll actually have more options than what I have here, but you'll still be able to do the same thing that I'm doing. I know it looks a little bit different. I think this bar's over here on the Yenka one. You'll essentially see the same thing. So this is the completed circuit. I'm just going to get rid of the whole thing now and just start you off on these component parts. So first thing we're going to go do is just introduce you down to obviously this bit here, the analog one there. Now down here you've got things like power supplies. Actually, you know what? We're going to go ahead and bring that battery in now, because if you look on option 1, we have a 9-volt battery on the side there. Just check anything else there. We don't need anything else for this right now. Going to go to our switches. Now you'll notice it has a push to make switch, which is this one here. So we're going to go ahead and bring that one in here and just rotate it around so it's in line with what you can see there, just to make it a little bit simpler on line up how you can see. You don't have to turn it sideways. It just makes it a little bit easier in a moment when we start connecting bits together. So obviously that's all we need in our switches there. Now, inputs, we're just going to check down here. We don't need any of these bits here. Now, if you remember to lesson before last, we did our research on passive and discrete components. Now, in the passive here, we've got a couple of resistors here. In fact, we've got 3 of them. So we're going to bring in our first resistor over here. Now, as standard, they come in as 10K, which is our resistor one. We don't need to do anything to that. We can leave that in. We can bring our second resistor in over here. Now, this one is 100K. So I'm just going to go in there and change that to 100. Then our final resistor over on the side over here, I'm just going to rotate that. Oh my goodness, there we go. Rotate that around 90 degrees because it's a little bit easier to work with that. Change that to 330. And instead of that, just to standard ohms there. All right. Now that's the 3 resistors we need to bring in. We still need to bring in our capacitor. Now, if you remember when you filled out that table in the lesson or last lesson when you was doing the research into the resistors, the capacitors and the diodes, you should in fact remember these 2 next bits we're bringing in. So we need to bring a capacitor in and a diode in, and these are our resistors. So on that table, when you filled out those, what the circuit symbol looks like, that should help you now. So we're done with our passives. We've got our resistors. That's perfectly fine. We're going to go into discrete. Now, yes, diode is in here, and that is the symbol. But if you look on the diagram there, it's actually a light emitting diode, which actually comes under the light output. So I know it's a little bit confusing. Doesn't matter which one you pick here. I'm just going to pick the green one because, I don't know, greens go. And I'm going to whack that one in there. Now, what am I still missing? Ah, yes, I need my 555 circuit. So, I believe, if I remember correctly, is that in the microcontrollers? No, it's in my integrated circuits. Here it is. There's my 555 timer. This is basically the microchip that kind of signals everything to go in the right order, and we'll go through that in a little bit more detail another time. For now, just know that's what you're bringing in there. And finally, what are we missing? Our capacitor, where is that? There it is, capacitor. And that's what we want to bring in here. You'll notice we need to change that to MF there. It's already 100, that's perfectly fine. Now, I know on the diagram, on the worksheet, it's got things like obviously B1, C1, R1, R2, R3, D1. They're just signals. Obviously, R1 is resistor 1, R2 is resistor 2, R3 is resistor 3. Don't worry that these don't have that written on it. Obviously, D1, diode 1, B1, battery 1, C1, and capacitor 1. We normally put that on circuit diagrams just to help us when we're labeling. But for this computer program, we don't necessarily need it. Now that's all the computer program, that's all the circuit diagram pieces that you need. Now we're literally just going to put bits together. So I'm going to start over here, connecting that up. We're going to connect our light up down here. There's a whole series of bits we've got to go here. So let's go over there to that bit there. What do we got here? This is going up to the top of our resistor over here. And this one is connected to the side of it. At this point here, don't stress too much about obviously what's going on here. It does get a little bit confusing here, but it makes sense later on, and we can just get these parts connected up. So move that across, it's a little bit neater. There we go. That goes there. This one will connect, no. Let's go to there, there we go. That will connect to there. That will connect to there. That will connect to there. I'll come back to that in a minute. There we go. Sometimes it's a little bit fiddly connecting these bits in. Don't worry, it's a little bit sensitive sometimes, but here we go. What are we missing here? That bit goes all the way over there. We have this piece that comes up to there. Right, you are supposed to connect to there, that's right. I'll move you back up there. Oh, for crying out loud. All right, let's try that again. Right, it doesn't look pretty there, but that's essentially the same thing as what we've got going on there. Final one, this one over to here. This one over to here. Oh, for crying out loud. It's, as I mentioned, can be a bit of an annoyance to get connected to the right bits all the time. Let's move that just up a little bit. Need to now move that down. And there we go. All the right bits are connected up. Now you can obviously neaten that up as you go. You can do bits like this. That can go up a little bit, keeps that a little bit neater. I'll leave that there. I'm not going to mess that up too much. All right then, so we have our battery connected to our resistor and our push to make switch. Our capacitor, this bit's quite important in a minute. We'll see what happens with that in a second. Other resistor, it's all connected to the 555 chip that we can see here like so. Other resistor and the LED light. Now, once you've connected all that up, we need to see what happens when we press the button. Now, when we press the button, I want you to keep an eye on the LED light. But most importantly, I'm going to show you what's happening with this capacitor right now. Can you see right now it's at 0? Now, as I press this button, I'm going to bring my mouse over here, and you can see that slowly draining down. Now, if you remember when I was talking about capacitors in that previous lesson when you was filling out the table, we was talking about it, think of it like a jar of, a mug of water or a bucket of water with a hole in the bottom that slowly trickles water out. That's essentially done the same with the energy here. So obviously when we've connected it up, it's filled that capacitor to the top with lots of energy. And as it's slowly trickling away, that light is still on, but you'll notice it will get down to a certain point and the LED switch will turn off. Simple timer light switch. Essentially, the idea is you press the button, your light will come on for a predetermined amount of time. That determined amount of time is how much power you've still got in this capacitor as it's draining out. And when it gets down to a certain point, it will turn itself off. And there you go. That's a simple timer mechanism with an LED light and a push to make switch. And that's the first example. There you go.